The IBM MQ event source allows us to use an IBM MQ queue as a source for cloud events with Knative and TriggerMesh. In this video, we'll walk through setting up an IBM MQ server for sending test events and configuring our source to connect to that queue and receive the events. First, let's start by spinning up the GTFLP tool, which gives us a console to watch all the logs and events in our namespace. I've updated the GTFLP release YAML file with my mat namespace, so now I will use kubectl to apply it. We can see the trigger and service get created, and we can see the K service is now available to us at this URL. Now we'll open a pair of tabs, one to watch the logs and one to watch the cloud events. We'll come back to these tabs soon. The IBM MQ event source repository is on GitHub and contains a manifest file to deploy an IBM MQ server for testing. You can see the password is already set to password, and the image is provided by IBM. The service will be identified as IBM MQ, and the deployment as IBM MQ server. Now we'll use kubectl to apply it to our namespace, and we can see that the deployment and service have been created. If we look on GTFLP, we can see the container that spun it up and the output at the console. Next, we'll get the pod that's running the IBM MQ server and forward a port to the console. Here's our pod. We're going to use kubectl port forward to the pod with port 9443 in our namespace. Give that a second to spin up. Now the port is being forwarded, and we can open the localhost 9443 IBM MQ console URL. We'll accept the certificate. Its localhost doesn't match up with the cert that's provided. That's fine. And then the console will spin up, and we'll go ahead and log in. The default credentials are admin, and the password is password with a 0 for the O. There are queues already provided with the instance. We'll go ahead and manage our QM1. We see the dev Q1. We'll click on that. And we'll go ahead and create a message for this queue. Our message is, "Hello, video watchers." We'll click Create to create our message. We can see the message there waiting to be processed. Now, let's go ahead and spin up a source for it. The config file kobe.yaml is a manifest for deploying our IBM MQ source that uses a new event, source, and target framework from TriggerMesh. Let's update it for our namespace, put in mat, and replace default. And we're going to send the events from the IBM MQ source to a K-sync. We'll use the default broker, which will be picked up by the GTFLP tool. We use kubectl get brokers in our namespace. We'll copy that URL and update our Kobe YAML with that. Now we'll apply that to our Kubernetes cluster with kubectl apply-f config Kobe YAML. Our IBM MQ source has been created, and we can use kubectl to see that it is ready. If we go back to the GTFLP logs, we can see that the MQ event source has been created. It is connected to the QM1 queue, and it has pulled the message from the queue and sent it as an event to our default broker. When we go to the event viewer, we can see that the cloud event has been displayed with our message, "Hello, video watchers." From the IBM MQ console, we see that after we refresh the console, the message is no longer in the queue. Let's create another message in our queue, time for a second event. Click Create, and it's immediately consumed by the MQ source and sent to our event viewer. Creating a third event shows this again. and the log scanner shows the output of the queue messages being consumed and sent to the default broker. We could easily send these to any other target or process them with a transformation. Once they're in TriggerMesh, they can go wherever they need to be.